I'm sorry, sir. Okay, this is going to be a really short lesson today. I just want to wrap up the rational inequalities and equations, and there's only one more I want to take a look at where we find a common denominator. Okay, very, very similar to the one that you had as a bonus on your test yesterday. Speaking of the test, your class average was 83.5. Okay, so very well done. A lot of people did really well. If your grade was a little lower than you would have liked, if it's less than a 70, you can retake. Now, normally I always give a week after the day it's due, so normally it would be next Thursday, but I'm going to go ahead and extend it because these next couple of weeks are going to be kind of unusual. Monday, we're not here because of Labor Day. Next Friday, I won't be here because I get to go to a professional development workshop, and you can tell I'm super excited for that. And then the following Monday, you're off again as well because I have more professional development to go to. So you're going to have until Tuesday morning, the 11th. So it's a week from this Tuesday. So anytime between now and then, if you're not able to come in during tutorials, let me know. We'll work out a time for you to come in. I have a different version of the exam you'll take. And of course, you know, by our school policy, you can only get up to a what? A 70, but that could in a lot of cases still be higher. So Tuesday morning, the 11th by 8:05, the end of tutorials. Okay, and then after that, I'll pass back those tests. We'll have any questions on those, talk about them. And then I've got a homework assignment we'll go ahead and take a look at for the remainder of the day, and that'll finish off our week. Okay, now I may or may not have mentioned this in the previous class, but if you do come across a rational inequality it looks like this, I'll just go ahead and say. You can't go immediately to your sign chart. You got to make sure of a couple of things. First, it has to be compared to 0. So whether it's less than or greater than, you need everything on the same side of the inequality, and you want to join everything into a single fraction. Okay, so there's two things I need to go ahead and take care of for this one. So 3 over x plus 2. I'm going to go ahead and subtract the 2 over x minus 1. Okay, and now we're less than or equal to 0. So I've taken care of the first part. It's got to be compared to 0 because that's telling you, do we want the negative or the positive intervals we were referring to on Wednesday? Okay, and here, what would we want? We'd want the negative. That's exactly right. So let's go ahead and combine these, and you need a common denominator. So what would that be here? There you go. It would just be a product of those binomials. All right, so I'm going to go ahead and create equivalent fractions just like you would numerically. So 3 over x plus 2, well, we need that denominator to be x minus 1. But we don't want to change the value, what the function is. We just want to change the way he looks so I can perform an operation with him. So that's why I've got x minus 1 over x minus 1. It's just a version of 1. Minus 2 over x minus 1, but he's missing the x plus 2. So same reasoning, less than or equal to 0. Now here I am going to go ahead and combine a couple of steps. If I were to multiply the fractions as they are right now, both of them would have the same denominator, which would allow me to subtract them. So I'm going to multiply and combine those at the same time. So we're going to have the denominator x plus 2. X minus 1. Now, what do I get if I distribute 3? 3x minus 3. Now, here's something that's really easy to forget if you're subtracting. You know, make sure you have to take the negative with it. You got to distribute that. So we're going to pretend it's a negative 2. So what am I going to have here? I heard negative 2x minus 4. There we go. The 2 times 2. And then, of course, this is less than or equal to 0. Now we just need to do a little bit of cleanup. You know, we have some like terms here. 3x minus the 2x is going to be a single x minus 7 all over the x plus 2, x minus 1, and now we're less than or equal to 0. And now the problem is just as we've seen in the other previous class. Okay, now I can go to my sign chart. Okay, so anybody have any questions or not sure where I got anything from in this process? Okay, then let's go ahead and get to it. The values that we take off of the rational function that I use to put on my sign chart, which remember is the x-axis. What do we call those? There were two names. One starts with a z. Zeros. Oh, not asymptotes. They could become asymptotes, but we say they make the function undefined. There we go. They more than likely become vertical asymptotes, but it's possible you could have a removable discontinuity or you could have a jump discontinuity. And we'll actually kind of look at those next week. All right. So why don't we go ahead and do this? Let's get somebody up here, because I talked about sign charts for a while. Who would like to go ahead and fill in the sign chart for me? Whoa, so many hands. I can't choose. Okay. Dylan? Okay. Dylan volunteers. Thank you, sir. Do you want to wear the stylish headset? Oh, he's good. Okay. He is good to go. All right. So he says 7, 1, and 2, -2. There we go. Now remember, we're taking each of those group factors, setting them equal to 0. We're looking for the values that make the numerator and the denominator 0. Perfect. Any value coming out of the numerator is a 0. The denominator is an undefined.
Yeah, do you want me to do the rest of it too?
Sure.
Okay.
So open or closed? What are we looking at?
Closed.
On all three? No?
Closed here.
Okay. Now why are those open? It says less than or equal to.
They're undefined. So.
Okay, we can, no matter what, you can never include the undefined. The only one you could ever possibly include is going to be the 0. Okay. All right, so he's choosing the value, and we're going to plug it in. So 0 minus 7 is negative, 0 plus 2 is positive, and a negative. So that is a positive interval. So will my answer include -2 to 1?
No, because you want everything less than.
That's right. Dylan says we want everything less than 0, so we want the negatives. Okay, he's choosing 2, and he's plugging that in. So negative, positive, positive. So that's going to be part of my answer. Is everybody okay with what he's doing? Anybody confused? Okay. Now let's choose 8. Substitute in for x, positive, 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 positive. And last up, -3. Okay, so he says negative, and there you go. Yes. Okay, I want to emphasize the sign chart is your work, but your answer is the interval notation, using the parentheses and the brackets. So -infinity to 2. Okay. Union. And the 7 has the bracket. Perfect. That's it. Any value of x I choose out of either of those two intervals are going to make this a true statement. That's what we're looking for. All right. Any questions? How's everybody doing? Okay. All right. We'll all go ahead